Hello everyone, this is the second part of my lecture on the method of variation of parameters for finding particular solutions of linear non-homogeneous differential equations. Let me first recall how this method works. So we are given a second order non-homogeneous differential equation. The problem is to find a particular solution of this equation. The first step is to find two linearly independent solutions of the associated homogeneous equation. And now the idea of the method is to find a particular solution of this equation in this form, u1 multiplied by y1, u2 multiplied by y2, where u1 and u2 are two functions of x. And we know that yp of this form will be a solution of the non-homogeneous equation if u1 prime and u2 prime are solutions of these two equations, of this system. Now we solve the system. It always has a unique solution, and then we integrate to obtain u1 and u2, and then the particular solution that we are looking for is given by this formula. Now I'm going to consider two examples. In the first example, we have to find a particular solution of this equation. The first step is to solve the associated homogeneous equation. The characteristic equation is of this form. It's easy to factor, so we have two roots, 1 and 4. Therefore, e to the power x and e to the power 4x are two linearly independent solutions of the homogeneous equation. Therefore, the complementary function is given by this formula. Now I'm going to apply the method of variation of parameters. We are looking for a solution of this form, which looks like this in the particular case that we consider now. Yp of this form is going to be a particular solution of the non-homogeneous equation if u1 prime and u2 prime are the solution of this system, which look like this in the particular case that we consider. Now we use the formula that we know from class to solve this system, and we get u1 prime equals this quantity, u2 prime equals this quantity. The dominators, in the denominators, we have the Wronskian of y1 and y2. So this determinant is equal to this quantity, this function, which is always different from 0. So therefore, it's easy to find u1 prime and u2 prime. The value of this determinant is right here, divided by the Wronskian, and we get this number. And similarly here, we get that function. And now we have to integrate. The two integrals are very simple, so we get these functions for u1 and u2. And then a particular solution of the equation that we are interested in is given by this formula. Slightly simplified, we get right here yp equals this quantity. And now, knowing yp and yc, we can write the general solution of this equation, which is given by this formula. Here c1 and c2 are two constants. One important observation, the function fx on the right-hand side of the equation is of this form, a constant multiplied by this exponential function. And we know that in a case like this, we can solve the problem by using the method of undetermined coefficients. We solved this, we applied this method in class, and we found this particular solution. Now, I would like to compare this solution with the previous solution, and we see that they're slightly different. But the difference between these two particular solutions is this function, which is a solution of the homogeneous equation. So the two general solutions are the same. Now I'm going to consider another example. Here is the equation. The problem is to find a particular solution of this equation. Again, we have to solve first the associated homogeneous equation. The characteristic equation is like right here. We have a double root, r1 equals r2 equals -1. So we know that in a situation like this, e to the negative x and x times e to the negative x will be two linearly independent solutions of the homogeneous equation. Therefore, the complementary function is given by this formula. Now I'm going to apply again the method of variation of parameters. We are looking for a solution of this form. In this particular case, this is this formula. Now we know that this function is going to be a solution of the non-homogeneous equation if u1 prime and u2 prime are the solution of this system. In the particular case that we consider, this system looks like this. Here is y1, y2, y1 prime, y2 prime. We know how to solve a linear system like this. We get immediately u1 prime and u2 prime in terms of these determinants. Again, as before, in the denominators, we have the Wronskian of y1 and y2, which is equal to this function that is always different from 0. So therefore, now it's easy to find u1 prime and u2 prime. This determinant is equal to this quantity divided by the Wronskian. We get this function, and similarly, u2 prime is equal to this function. And it remains to integrate. The two integrals are not completely obvious, but they are doable. In both cases, we are going to use integration by parts. For the first integral, we choose u equals logarithm of x, dv is x dx, therefore du is 1 over x dx, v is x squared over 2. Therefore, integrating by parts, we get this quantity, which is equal to this function. So therefore, u1 is equal to this function. And similarly, integrating by parts here, we get u2 equal to this function. Now, putting this together, we are going to get a particular solution of this equation. Here is u1 multiplied by y1, and here is u2 multiplied by y2. We simplify and we get this function, so this completes the solution of this problem. Now, knowing yc and yp, we can write the general solution of this equation, which is given by this formula. Two remarks are in order. It's important to understand in this case that the function fx on the right-hand side, which is this one, cannot be handled by the method of undetermined coefficients. So the only way to handle this problem is to use variation of parameters. There is one more example given in the text. A particular solution of this equation is found there by using the method of variation of parameters. Take a look at example 11 on page 194. And now some additional information. A PDF file of the slides that are used to create this video is available on Blackboard. You can download it. It's a much smaller file. And also, there'll be a homework assignment on the method of variation of parameters. Please check the assignments on Blackboard. And this is everything for today.